This is now the third tutorial. Um, third tutorial we're gonna have on the content on this GitHub repository that has all the codes we were looking at. So for this one, this is the second post processing part. We're gonna go post processing, thermal calculations, and get this code over here, the only one. On on this part, basically, we're going to calculate the thermodynamic properties well, the ones that are like calculated after like divide temperature, internal free energy, total free energy, and vibrational entropy as well after we got internal energy, lattice parameter, and bulk modulus from the simulation data directly through a virtual fit. So so I went here, and then um after it downloads, I'm gonna go ahead and take this to where we had it before, which we first in the first tutorial where we generated this all the lamps data, if you remember. And then at the end, we made all the calculations, we gathered the data, and we were left with this CSV file over here, which for this composition states the value of internal energy per atom, volume, bulk modulus derivative, lattice parameter, and their respective error or standard deviation. Basically, this is standard deviation. So this is an input we need to give to the code we just downloaded, the thermal code. So for this, I'm gonna go ahead and create a new CSV file, which is gonna be titled. mm, it's gonna be named like this right here. So it's gonna be named. We said EV FEB this from this order because we're doing this order here. If this was order, we will just name it word like this. But it's gonna be this in this case, and then this is just the name the program, the Python code we just downloaded. Is gonna recognize for like importing the file. It's just what the setup takes, and then the file itself needs to be in this format right here. I had one of the previous ones, the ones we used for the previous simulations on the paper and all that. So it needs to have the same the following name convention: if composition, then vanadium composition, and then all these labels over here: internal energy, and then it says the temperature, and the order or disorder, the error, and yeah, basically all these labels will be the same for a given temperature, right? For example, this is a previous one, like all the data for like here's the composition, and then you get like the all the values like bulk modulus, um, lattice parameter, and then oh yeah, confidential entropy, and then it starts with 300 Kelvin. So in this case, I'm just gonna copy one of the temperatures for this. Oh, it didn't work. Hmm. all this I'm doing right here, I mean, I'm doing it manually just because I have four examples, so like you can understand what I'm doing. But it doesn't have to be manual. I mean, we actually have codes that automate this and like for gathering the data from like if it is a lot of simulations. So I'll go over them like in another tutorial. Just here, just like to make more sense of what I'm doing. Then this is point 0.5 composition, and we said 1500 temperature. So I'm not here with the labeling, like all the changes. And so what I'm gonna do for like this time is I'm just gonna copy these parameters manually. So again, there's codes. We have codes that like do this, but I'm just gonna do this time so like you can visualize better what you see. So internal energy or value, bulk modulus, and then the error, derivative, and the lattice. And then the configurational entropy. I'm just gonna take it from directly from here this time from the value we had, which is, let me see if it is zero point 0.5. Yeah, I'm just gonna do this time because so we don't have that like actually integrated in the codes, which maybe should, but um we just calculated this like one time maybe for all the compositions we had, and then we didn't do it again, and we just like copying all again because this doesn't change with temperature. Like it's just dependent on the composition value, which is the same for all the ones we use in for this project. And it's calculated with like a super simple equation, so it's not a big deal. You can do like a separate code to that, and I'll put that on the GitHub also. But okay, yeah, this should be it. And then I'm gonna open the code we just downloaded. Thermodynamic quantities and error calculation. And then if you scroll all the way to the bottom, you'll see all these uncommented lines, which honestly we can delete for now. And then we're gonna see that this is the actual activation function, let's say. Then this is just naming, but we're gonna get the right temperature. And then this is the function you need to call if error calculation, and then you need to pass either this or as this. It needs to be either for this to work. And just on the label, like order and disorder. Then disorder, and then you have to put in the temperature, 1500 in this case. It shouldn't take that much, especially because it's just one composition compared to nine we were doing before. But yeah, calculations are a little involved. So I'm just gonna speed up the video and finish it when it's done. We're done here now. And then if we go to the folder where I was doing the simulations, we're gonna see a bunch of output files, which will and then we're gonna see this one over here, data frame output, definitely 1500. And this is the one that contains all the information we need. Divide temperature and then the standard deviation. And then these two parameters are just like for graphing purposes. Let's say this is just this plus this, and this is this minus this. It's just a naming thing. Like, yeah. No, I'm sorry, not a naming, a graphing thing. Like for the error bars and all that. It's not really like a calculation. Then we get entropy, and then the free energy here. So yeah, this is kind of it. I'm not sure about this configuration entropy actually. I'll double check. It shouldn't be. I'll double check this one. But yeah, um, but yeah, this is it. Like you get your final results for the right temperature and all that. So yeah, I think this concludes the first series of tutorials. Um, like a simple version. The next tutorials are gonna be like how to actually implement these codes at scale with the other codes we have. So like if you start like, if you're gonna like start like doing a lot of simulations, you need like a code to like gather data from multiple folders, and that's what we have basically. And I'll also be posting tutorials on how to use them because it was better for this time to keep it simple to really like see what's going on first, and then we will take it on scale. But yeah,